for the first part of today's lecture series, I'll be giving to you an introduction essentially on software-defined networking and its relationship to other adjacent technologies such as network functions virtualization and OpenFlow. Now you might also be wondering, no, because um, recall that in the previous sessions that you have already attended, most of the topics and discussions have been focused more on cloud computing, also in radio access, okay, and essentially the main bodies of Open RAN, no? And you might be wondering, these technologies that I'll be talking about, um, it's not really much on the radio access domain per se, but it also tackles or it rather plays an important role in enabling the entirety of radio of Open RAN as a technology. Now, think of this technology as sort of like a bit of a step away in the radio access domain. So recall that in your mobile communications, no, the entirety of the mobile communications ecosystem revolves on essentially three major domains. You have wireless access or the access domain. So this is where most of the radio would be found. You also have the transport. So in the transport domain, this is where most of the fiber, microwave, essentially the connectivity that is responsible for ensuring that all of your network elements are connected inside your network. And finally, you have the core network, where all of the services that you are enjoying in using the mobile network, no, can be found. So this is where your gateways would be found, your PGWs, for instance, no, your signaling SMS nodes, no, we're still using it, in fact, no, among other things. Now, the module that I'll be talking about for this morning primarily focuses more on the upper two portions of your network, specifically in the transport and in the core domain. So recall that in the previous sessions, the cloud computing or aspect of Open RAN in general, no, is actually split across the different domains. No? So you have representations or use cases of cloud computing that can be found in the access domain, similarly also to transport and to core. No? But it gives more emphasis on the transport and the core domain, primarily because the cloud workloads wherein it would be hosted in are most of the time can also be deployed as virtual machines and software-defined network elements, which is something that we would be talking about for this morning. So having said that, no, I've decided that for today's session, we'll be discussing briefly the different technologies and how they are also interconnected with each other. Meaning, okay, we know that SDN is a different technology to NFV, and we also know that OpenFlow is essentially an enabler of SDN, but it also plays a part in NFV. So having said that, I've laid out today's discussion to be a bit of everything or little bits and pieces of at least to give you an understanding of what these technologies are about, how they are also interrelated with each other, what are its advantages and disadvantages, no, and how do they fit in the overall picture of Open RAN. Okay. So here's my overall module objectives. By the way, no, these are courses. So the one that I'll be giving to you is in fact just a summary of the other foundational courses that we are also offering in Asia Open RAN. So mine here, the topic that I'll be giving specifically focuses more on the SDN, NFV, and OpenFlow technology. So we're throughout the courses, so I'll just give you a bit of a pitch in here also of the course, no, because it covers several topics as well as a deep dive on the individual technologies related to the thing. Okay, but for now, I'll just give you an overview of each. Okay? And in fact, no, you may have also noticed that in the pre-test a while ago, no, there is also another technology related to this entire concept, no, which is virtualization. Okay, so later on, I'll also be discussing what is also virtualization. Okay, so having said that, what is software-defined networking first? No? Let's take a step back. So let's take a step back a bit and have a bit of an understanding first on how is a transport network, specifically the IP network, are connected, and how do the different components are communicating with each other. So normally in a typical IP-based network, no, you have your switches, right? And I would assume that everybody here knows what a switch is, no? So we know that switches are capable of forwarding our packets on the L2 or layer 2 domain. So meaning that it is responsible for passing packets point to point wise. Okay. Now, if we're going to deconstruct what a switch does in a functional perspective, it can essentially be broken down into its two constituent components. Okay. So think of it that whenever you have a switch connected in your network, it's essentially serving two roles. Okay. So one is a control role wherein most of the configurations are being done. And you also have the data role or the data plane. So these are roles, and in some definitions, no, these can also be considered to be planes, okay, or not necessarily planes of resistance, but sort of like your layers, the functional layers of a switch. So what do these layers do? In a switch, a data plane or the data plane is responsible for just essentially forwarding the packets. So this is the plane where you can find your decapsulated packets up to the L2 layer or up to the layer 2, no? And essentially, this is also where your data can be found. Okay, so that's the data layer. If I were to simplify it. And apart from that, you also have the control layer. So remember that the switch is a network element. It is a device. And for it to forward packets properly, it also needs, of course, configuration. You need to also tell the device how will it forward that packet. Where will it forward it to which specific port, right? And for us to do that, we configure it through its running configuration files. And at the same time, we also depend on protocols to ensure that when a packet is received by the switch, it knows what it would do. It knows what to do with it. Okay? So based on several protocols, sample, a spanning tree, for instance, configure it with a VLAN, okay? Among other things, no? So these are essentially instructions on what a switch can do once it receives a packet. And if, say, for instance, it doesn't know what it can do, then essentially it drops it. So think of the control plane as the plane that is responsible for all of the configurations being done on that specific device. Apart also from configuration, no, the monitoring, the fault monitoring, performance monitoring, okay, operations and maintenance are also being done somewhat in the control plane. So meaning if I want to identify, suppose I've already deployed my switch in my network, of course, we need a way to monitor our switches. So this is where the ONM interface would be coming in, wherein it's a separate port or a separate interface wherein it forwards all of the necessary metrics and monitoring data to ensure the overall health of that switch. No? So it's also being done in the control plane. Now, it's a bit of a long-winded discussion here, but bear with me. No? When we now connect, okay, so it's simple to understand it from a single device perspective, meaning that we're just looking at a single switch. The complexity already comes into play, or it already comes into mind rather, when we already are connecting that switch to a given network. Right? And I believe some of you have already experienced at least how you can set up your own network, no matter how small it is or whatever the scale is, no? And it essentially involves not just physically plugging the switches, but also doing some configurations. Now, what do we normally do when we configure a switch? The first thing that comes into mind is that we log in into the command line interface of that said switch, or we depend on the GUI, the web-based graphical user interface of that switch, and we do the necessary configurations on a device level. In other words, we perform configurations, we perform monitoring, we also do fault monitoring and ticketing per device. Get my point? So if, for instance, within my topology, a certain switch becomes faulty, we now depend on the protocols to ensure that there is still network consistency or there's still coherence in our network. Okay, so meaning if, say for instance, if I take my switch here and one of these switches, so let's take this switch and this switch goes down, we then depend on the available live switches to ensure that packets are being forwarded from its source to destination, no, through the use of their configurations and also their protocols. Okay, so we do this again on a per device level. So meaning we go into the individual devices and do them all manually. Okay, so having established this context, no, so where am I coming here? We now approach or we now define what is software-defined networking or SDN as a technology. Remember that concept of switches being or having two layers, which is the control plane and the data plane. In SDN, you are essentially centralizing the latter, okay? Meaning, instead of doing all of the controls and all of the parameter configurations, all of the fault monitoring on a per device level, you essentially do it only on a single node or in a single network element. And this element is what's called the SDN controller. Okay, this is also important, or we can say that this is the overall heart of this technology. In other words, you are taking the different control functions of the individual switches and centralizing them in only a single network element. Okay, this process is a move away from traditional network. So the context of traditional network here comes from IP conventional networking, wherein we do configurations on an individual device level. Okay, this ensures that decisions are based and are being done rather coherently, no, via a single centralized control node. Okay, without having to touch any individual switches along the way. So if I were to simplify what SDN is, this is what it does. You just centralize the control plane into a single node. So essentially decoupling it on the per device level. So what does this leave us? No? So in other words, since the control plane is already centralized, this leaves us with only the data plane deployed individually on per devices as individual switches. So essentially the switches here become what is being called as dumb switches. Its only main functionality now is just to forward packets from point to point. Okay? Now, in SDN, because we are taking, so if we're going to deconstruct the entire term, software-defined networking, there is that element of it being software-defined. So similarly also into your Open RAN, you have SDR, software-defined radio. No? In the transport domain, we also have SDN, software-defined network. So the context of software-defined here is that you're no longer dependent on having the function deployed in dedicated hardware. You're essentially decoupling the function from the hardware itself. Okay, so SDN moves the control plane that determines where to send traffic to software. So if I'm going to go back in my architecture here a while ago, even though the controller is already centralized, it doesn't also imply that the controller is also a physical box. So you can think also of the controller to also be deployed as purely software. In fact, no, you can even deploy it as a virtual machine. More of that one when I discuss virtualization. No? So it's really a step away from how we normally do IP networking, such that all of the different functions are no longer being tied up in a single device. This also ensures that, of course, why are we even doing that? No, later on, I'll be describing to you the different advantages, but also keep in mind that I'm not also trying to put SDN here as sort of like the end all be all solution. Okay, like all other technologies, no, I mean, we are already in the technology space after all. There is no such thing as a magic bullet in technology. There will always be advantages and also limitations and disadvantages, some of which I'll also be discussing. Okay, so going back now into the SDN, how do we now deploy it as an architecture? Okay, and what are its different features and benefits? Okay, so SDN allows network architecture administrators, no, and even engineers who use software-defined networking to program and control the entire network via a single pane of glass through the SDN controller. Now, the SDN architecture follows a somewhat general architecture. Let's put it at that, okay? Normally, the SDN architecture is represented in three layers. Okay, so what I say here is that normally it's because unlike other technologies such as mobile communications, wherein we are somewhat mandated into following specific standards, no, and regulations, and uh, compliance points, no, SDN is somewhat lenient because instead of giving everything to be strict rules, no, we follow guidelines and models. Okay, so in a typical SDN architecture setup, no, it consists of three layers. Okay, you have the infrastructure layer, which is the lowest level. You have the control layer, and finally the application layer. Notice also that in my discussion a while ago about the SDN architecture when compared to your IP networking, no, you are essentially decoupling or centralizing the SDN controller. And um, consistently enough, no? So to be consistent, you'll notice that the controller also resides in the control layer. Now, the different layers in our architecture are then interconnected with what's called APIs or application programming interfaces. More of this one later. Okay. And another observation here, no? So if I'm going to look at this diagram of the architecture itself, you may have noticed that specifically the APIs, the southbound API is where OpenFlow would be residing. Okay? So meaning OpenFlow, which is essentially a protocol, no, also plays an important role in ensuring an open source based SDN architecture. Okay? And it plays in the lower part of your architecture. Okay. Now, brief explanation of the different components inside your architecture. So at the topmost, you have the application layer. Now, if you have already a background on networking, IP networking here, no, we are also acquainted with the 7 OSI layers, right? We also have the 4-layer TCP IP layer. And regardless of what model you use, no, or what representation you use, always but always the top portion would be either the application layer or somewhat a terminology similar to it. Okay. In SDN, it is also a similar pattern. So in the application layer, it's not really an application, or what you'll find in this layer are not really applications in the uh, desktop context, if you know what I mean, no? So, or not in the mobile phone. So whenever we say app, no, the first thing that comes into mind that in desktops or in computers, no, this is where your Microsoft Word would be coming in, your games, no, your spreadsheets, your web browsers, no. So it's not really in that perspective. Remember that uh, an application is a piece of software that does a specific task. And we're taking that definition in this context. So the application is in fact the layer responsible for hosting the different services that you want to deploy in the architecture. Okay? So the app here is actually a representation of services that can be found to be available in the network. And what are these services? Normally, this would come in the form of what's called L7 or layer 7 services, such as firewalls, load balancers, okay, web proxy, detection systems, spam filtering, among others. Okay, so that is where um, these features in your network can be found. Okay, one layer lower inside the application, or one layer lower to the application layer is the control layer. So this is where the heart of the architecture or of SDN would be coming in. This is also where the controller resides. This represents the centralized SDN controller, and it resides either as a server that manages policies and traffic flows through the network, or even as a virtual machine. Okay, so remember that the software-defined component of SDN removes already the limitation of having that application bound in a single piece of hardware. Meaning that if, say, I have a hardware that is currently hosting my controller and it goes down, I can easily just take out that application or take out the controller, transfer it to another server. Okay? So there. Then finally, one layer lower into the control layer, you have the infrastructure layer. This is now where your physical switches would be residing. This is also where the data plane would be residing. Okay. Essentially, the role of the infrastructure layer is just to forward your network traffic. Okay. So connecting all of these layers, you now have your APIs or application programming interfaces. You might have also encountered this terminology in web development or software development. The context here is that APIs are normally used for the layers to communicate with each other. So that's why in a typical architecture, no, you have northbound APIs, which is the controller connecting towards your application layer. So meaning it is the controller who is calling out the different services that you want to deploy in your network. And you also have the southbound APIs, which is the controller talking towards your forwarding switches. So meaning the reference of your APIs is with respect to the SDN controller itself. So meaning you call northbound APIs, it's because it's the controller going up towards your application layer, and southbound APIs is the controller communicating downwards to your forwarding switches. Okay? So there. Now, I mentioned a while ago that SDN in general, no, even though it is a technology that somewhat improves the um, overall management and traffic forwarding than in a typical IP-based network. Remember that like all technologies, it also has advantages and disadvantages. Okay, so first off, let's highlight if I were to compare an SDN-based network to a conventional IP-based network, no, how will it compare? Okay. First off, definitely SDN the functions themselves are already software-based. So what does it mean by that? It means that the functionalities are no longer being tied up to a dedicated piece of hardware. Back then, when we are using or when we are deploying switches, no, the functionality of a switch is also tied up to that specific device, to that network element. In SDN, however, suppose I want so I'll show to you or I'll describe to you another example. Suppose I have or I purchased a switch that is capable of doing VXLAN. Let's take it that. Okay. And this switch, I've been using it for 3 or 5 years already. And the hardware of that switch has already degraded in time. Okay. But I still want VXLAN as a feature inside my network. Okay. So what do I normally do in typical in conventional IP networks? No? Since the hardware has already degraded in 5 years, no, I need now to replace it. Okay? But I still want the VXLAN capability available in my network. So what do? I purchase or I contact my vendor provider and then tell them that, hey, can you give me another hardware or can you give me an identical switch that offers this VXLAN service enabled in my network? So what they would do, they would also purchase or procure the hardware that is somewhat identical to it if by chance it is still available and make and offer it to you as your customer. Okay. Now, the problem lies is that the availability of that replacement switch. What if that switch has already reached its end of life? Or in worse scenarios, end of manufacturing. No? If say for instance, yes, you may have purchased that switch in example 2019 and the vendor can no longer and say for instance, let's take it one step further, that switch has become faulty and you want to replace it because one of the cards is already faulty. So again, you contact your vendor and say, hey, the card of my switch right now is already faulty. What can you give me a replacement switch for it? No. But the problem is, for instance, what if that switch has already reached its end of manufacturing period? In other words, the vendor is no longer manufacturing that same model, no, for it to offer to its customers. So you're already, you have already experienced a hurdle here, wherein if you want that same identical switch, then it can no longer be offered to you, right? So what does the vendor do? They offer a newer version of a newer price. And of course, this is also another hardware. So that is just on the replacement aspect of it. We also have to consider procurement of said hardware. Because it is hardware-based, we also have to consider the lead time of this equipment. In other words, we also still have to, if say I'm just going to replace my switch, I still have to consider the lead time of how long will it take for that switch to be delivered on site and also pre-configure it. Okay. Contrary to say having it as, so that is one plane of it. What if we take it as a software based? So having said that, now instead of deploying a physical switch for it, what if you just deploy a virtual switch? And this virtual switch is deployed in already existing servers that you might already have on premise. And it's just a matter of instantiating a virtual switch so that you can offer it into your network in what? Matter of minutes, in a day. Okay. So the turnaround time is already significantly reduced. So that is also an advantage of having it software based. Other examples, no? So in in traditional or in conventional IP networking, control is often decentralized. So meaning if you want to say actually control and configuration is decentralized. In other words, if you're trying to perform any configurations in a specific device, you have to log in individually into those devices and do the necessary works or tweaks. Okay? But in an SDN environment, because you are already centralized or you have already centralized your configuration and control in a single network entity or in a single node, all you have to do is to log into that SDN controller, and it's the functionality of the controller to propagate the configurations towards its forwarding switches. So, in other words, you have simplified the management of your network. Okay. Now, the last portion or the last part is security. Now, because in conventional IP networking, you also have to make sure that you perform the necessary procedures to make sure that the devices themselves are, again, less prone to attacks and is giving the least amount of risk into your network, right? So how do we do that? We implement security, again, independently or on a per device level, meaning you have to do some hardening or shutting down of unneeded ports. No, you go into the individual devices, log in, and then you do port shut. You disable all of the unnecessary protocols. Okay, you do these ones individually. Okay, in an SDN environment, because control is already centralized, you can also pass enforcement centrally, meaning you are now also dependent on the controller to ensure that security mechanisms are propagated across into your network. There's a bit of a caveat here, however, okay? Because I've noticed here, I've also included here a caveat, no, na security having it centralized can be both a strength and a disadvantage. Okay? So, how? Because remember that you are also centralizing control in a single network element. You also have to make sure that security is also strictly implemented in that single controller. In other words, if that controller gets infiltrated, if it gets attacked, by example, DDoS, for instance, then essentially the entire network also goes down. So again, no, there is a somewhat a balance that needs to be considered when we are also implementing security in an SDN environment. Okay? So, having said that, what are its overall or what are some basic benefits that you can get when you deploy SDN? So, number one is, of course, simplified policy changes. So, it also reflects on having a centralized controller. Because policies are already being propagated or centralized, no? All you have to do is to configure the controller with the necessary policies that you need, and it's already its role to propagate it across your network. So having said that, you also have simplified or centralized network management and visibility, reduced hardware footprint and OpEx. So remember that because it is software defined, you don't necessarily have to deploy hardware 1:1. Meaning that for every function that you want to deploy into your network, you don't necessarily have to deploy an equivalent device, no, for it to work. You can, in fact, just, if you have pre-existing hardware already and capacity-wise, it can support the SDN controller, you can use that. Okay? Therefore, reducing hardware footprint and in the bigger picture, reducing also your operational expenses or OpEx. Okay? And another benefit here is that because everything is already configurable in the software specific or in the software domain, no? Meaning that essentially these if you're going to drill down into what SDN control is, remember that these are software, so you can work with it as if you are working with regular files, no? It also opens up means of innovation, okay, means of new techniques and approaches, okay, that is normally also not available if your functionality is deployed or dependent on hardware. So you'll notice that also in the fourth benefit, no, this also somewhat shares the same benefit as what you would also have in your Open RAN. Remember that, or in your software-defined RAN, you are already decoupling the functionality from the hardware. So you can play around with the hardware, no, or sorry, with the functionality without having to necessarily purchase dedicated hardware for it. Okay, so on one side, you have benefits, you have its strengths. Of course, on the other, you have your limitations and challenges. So I've already highlighted one of them, which is security. Okay, you are also with the cost of simplifying management comes also the risk of having a single point of failure. Okay, and if this is targeted by an attacker, okay, and proper security measures haven't been implemented, then we know what would follow. Okay, so this also comes into mind that in practice, no, in the industry, of course, we do not deploy the controller as only a single node. Okay, keep in mind that whenever you may have also noticed that whenever I talk about the controller, no, I say it to be a single logical network element. This is because in practice, no, in real life scenarios, you don't necessarily also have to deploy only a single instance of the controller. Oftentimes, what you would find is that it is set up using also high availability guidelines and principles. So what do I mean by that? One example of deploying of one deployment example rather of SDN is that you might have an active standby setup wherein only one controller is functioning at this given time, but on the premise that this controller goes down, another one is able to take its place. Okay, this doesn't just also concern the availability of these instances. You also ensure the availability of their logical connectivity, meaning the connection between the controller towards the forwarding switches. You also implement what's called redundancy in logical connections, meaning that, of course, if this controller goes down, no, its corresponding interfaces and connections downwards and also upwards, no, you need to replicate it into the standby setup so that once failure happens, the other one is ready to take its place. Okay, so the content, the scenario here doesn't just apply in a failure scenario, but also can be applied in a security perspective. So example, say your controller goes down because of a possible DDoS attack, no? The other one is able to take its place while you are working on the other node. So that's just one example. Okay. So other challenges, you have unclear definitions. So currently there is no established definition of how you can deploy SDN. In fact, there are different iterations of how you can deploy SDN in general. Okay, think of this technology existing in a spectrum, meaning there are really hard definitions, or they are inclined towards having a separate controller and then having SDN dedicated forwarding switches. So that's on one side of the spectrum. But on the other side, you also have small-scale enterprises that are just deploying virtual switches and having the controllers deployed as a VM instance. So with that spectrum also comes an unclear definition to say that what is really SDN, what is also non-SDN. Okay, so how do we make sure that what a vendor is also proposing, for example, to an organization is legit SDN? Okay? So that also leads me to the third point, which is market confusion. Some networking initiatives are often mistaken for SDN. Okay? So meaning there are some vendors or there are some providers who market it to be SDN, but when we already assess it, the SDN component is no longer there. Okay, so how can we really identify if something is truly SDN? We go back to its original definition, separation of control plane from the data plane. Okay, so if that simple definition cannot be satisfied, then we then ask the next question, what kind of solution is being offered to us? Is it really SDN? Okay, so there. Now, next one, slow adoption and costs. The technology itself, if you're going to look at it from a bigger picture, no, this is not a relatively new technology. Okay, in fact, no, AI also, the one that's gaining traction nowadays, is also not a new technology. It's just gaining popularity and the overall market trend, especially in technology, in our space. No? It's also similar here to SDN. It's been around since 2011, in fact, no, but despite its more than a decade already of existence, no, adoption is also relatively slow. Meaning, not all companies are still towards adopting a full SDN environment. And it's still also okay for them because it depends on their requirement. Okay? Now, I mentioned that SDN also resides as a spectrum. So in terms of how you also deploy it, no, you have different approaches. So here are just some examples on how we deploy SDN. So you can deploy it using only a simplified protocol, meaning if you have this protocol enabled in your network, even though you are using existing switches, you essentially have an SDN deployment already. Okay? So that's one. Another one, what if I just use APIs, no, to control data plane, or I use APIs in order to separate control plane from data plane? That's also SDN. Okay. What if I have an existing network that functions on one layer? It is used for traditional networking, I would say, or conventional networking, but running on top of it is another logical layer, and that layer is purely software defined, okay? And different network elements are also functioning on top of it, so that's what's called an overlay model, okay? A virtual network is running on top of an existing hardware infrastructure, so it can also be considered as SDN. Okay? And of course, with all of these available technologies in hand, no, you can also pick and choose whatever you want. You have hybrid SDN. And this is the fourth one is in fact the most popular and most uh, conventional, I would say, no, the most available deployment type, no, in most network environments that we have. In other words, you can also implement SDM with an existing traditional or conventional IP network, meaning that a portion of your network is running the typical, for example, BGP setup. Okay, but there is a portion of it that is also running SDN. Okay, some um, enterprises or companies, in fact, have this approach because, let's face it, it's more practical. It's easier for them to adopt a technology if it is isolated from an existing network, you know, and especially if this network is it's less risk for that organization to do a complete overhaul compared to, say, just having it a small scale of it with the least amount of impact. Okay, so it really depends. Okay, so that's just my Okay, so we're done with the concepts of what SDN is as a technology, and we've also discussed the architecture in general, its benefits and disadvantages. No? And you'll notice that in my architecture, I also briefly introduced to you another terminology, which is, in our case here, OpenFlow. So what is it? No? Remember that OpenFlow is a protocol residing in your southbound API. So this is the protocol responsible for the communication between a switch and the controller. Okay, is this the only protocol for you to have SDN? Of course not. Okay, but the reason why we are also highlighting this is because this is also an open source protocol. Okay, so meaning that if you have, or say you are a vendor manufacturer and you want to implement SDN and you don't want to um, create a protocol from the ground up, okay, what you can do instead is to base the protocol or the functionalities of your switch using the OpenFlow protocol. Okay, so what this does, this is a standard, no, defined by the Open Networking Foundation, the OONF, for implementing SDN in networking equipment. Most of the time, if you are, or nowadays, if you look into switches and you look into its spec sheets and you see that it is OpenFlow compliant, then this switch is it can be used in an SDN environment. Okay? So it defines the interface between the controller and the switch. So it works in the southbound API. It allows the controller to instruct OpenFlow switches on how to handle incoming data packets. Now, logically speaking, the OpenFlow architecture can also be overlaid in the SDN architecture. Okay, so you'll notice that the OpenFlow controller here, no, so it's just actually you have a platform such as Open Daylight, for instance, that already also has the OpenFlow protocol pre-embedded inside of it. You just install it in, say, a virtual machine, and you already have an SDN controller in hand. Okay, and then all you have to do is to connect existing OpenFlow compliant switches to your controller, and essentially you have an SDN network. Okay, so the OpenFlow controller maintains the protocol communications channels to the switches themselves. So again, it works in the southbound aspect of it. Okay, but also the northbound API may also be viewed as an abstraction of the network. So meaning, although most of the functionalities of the OpenFlow protocol, no, is done on the southbound, it also offers capabilities on the northbound. Okay, you in fact can enable OpenFlow as a protocol through an SDN platform. So you just install it, no, and you can already have OpenFlow as a protocol in that said controller. Okay, an example of a platform for SDN is Open Daylight. Okay, so Open Daylight ODL, this is an open source platform. You can also look at this one up in the internet. And it's essentially an SDN controller platform. Meaning if you want SDN into your network, you can download a copy of it. And if you are acquainted with virtual machines, install it in a VM, you already have your controller. Okay? So there. Now, when you implement OpenFlow as a protocol, no, it also deconstructs a switch to have these functionalities inside. Okay. In our course, in course 412, we also offer a deep dive on on how the open flow vSwitch functions and the different capabilities inside of it, but I won't be discussing it here na due to time, no? So there. But at least an overview on how OpenFlow works is made available to you now. Okay, so we've discussed SDN, we've also discussed OpenFlow, and you may have also observed that this is all about having functionalities completely decoupled from hardware. Okay? Meaning that you are already removing the dependency of the functionality from hardware. We have this term in the industry, no, which is called a monolithic approach, wherein, or an appliance-based approach, wherein if say I want to deploy a network element, it's when I purchase it, no, it comes with the hardware itself, along with the software component of it and the features, no. And if I want that network elements service made available, for instance, on the premise of a faulty scenario, and the hardware is already degraded beyond repair, I have to purchase a replacement for it. The problem lies what if, again, in my example a while ago, the hardware is no longer being manufactured by the vendor, hence it becomes obsolete. No? What if my hardware is already in, I don't want to say antiquity, but it has already reached its end of useful life. And but you still want that service made available in your network. So in other words, you just want the functionality of it. Okay, you just want the feature of it, no, and you don't really care much on how the hardware would work, no. In fact, no, it's actually also the hardware that is purely responsible for, or the one that is hindering the overall functionality of it, no. So is there a solution for me, no? So come another technology which is called Network Functions Virtualization, or NFV. Okay, so its functional, its purpose, no, not really, also functionality, no. So NFV, this is also a technology that is similar to SDN. Okay, so recall that in SDN, no, you are decoupling the control and the data plane. You are splitting them by deploying them as software. Okay, so one thing about SDN is that when you do that said decoupling and removal of dependency to hardware, there are different approaches on how you can do so. Okay, one of them, in fact, is NFV. Okay, so an approach to deploy SDN is NFV. Okay, so what do I mean by that? No? So what is now NFV? So Network Functions Virtualization, this is a way for us to utilize virtualization technology in order to, I don't want to say emulate, but to mimic the behavior of hardware and have it available as virtual machines, VMs in a way. Okay, so it is a way for us, or it's a technique, no, to virtualize services that may traditionally have been run on proprietary hardware. In other words, through NFV, you can decouple software from hardware. Okay, services can then be packaged as VM instances or virtual machine instances on and have it run instead of dedicated hardware, commodity hardware. Okay, so instead of back then, if you want to say deploy coming from core, no? Say for instance, I want to deploy a 4G PGW or packet gateway, no? I have to purchase a hardware intended for a PGW. meaning I cannot repurpose my hardware to be something else other than a PGW. Can I use my PGW hardware as a server for, say, hosting a website? Of course not. Okay, because the hardware is just intended to function as a PGW. Now, it differs, or this is where NFV would be coming in. What if instead of you purchasing a dedicated hardware for a PGW, you just purchase a server, for instance, Dell, no, or HP, and have a function of a PGW running inside of it? That is NFV. Okay? Another advantage here, no? Suppose, in terms of capacity, the payload can no longer be catered by one instance or by one PGW network element. I need already to do an expansion. So what do I do? In traditional network, I have to purchase a dedicated hardware, another box for PGW. Again, this also comes from along with it comes the turnaround time, the procurement, the cost, no, for another hardware. Okay, but what if instead of purchasing a separate hardware for it, if I already have existing servers in my data center and it's able to cater or it's able to host a virtual PGW, then I can just deploy it there as a virtual machine. It saves me the trouble of procuring another set of hardware, another set of turnaround time to have it integrated into my network. So it saves a lot of resources in general. Okay, all you have to do is to just purchase the image file of that PGW, and if you already have existing resources in your data center, have it deployed there. Done. You have a second PGW instance. Okay, it is in fact, so NFV in general, it is one of the primary components of the telco cloud or telecommunications cloud, which is currently also reshaping how we make telecommunication services available to the customers or into the industry in general. Okay, with NFV, dedicated hardware is not needed every time a new network function is deployed, meaning that it comes from the context that you don't have a complete tie up to a function, no? And instead, if you already have available resources, use those resources. Okay, so here, similar also to your to the conventional IP networking and SDN. So we also have here a comparison. What does it mean for a function to be NFV based? No? So normally, whenever we deploy a network element or a network function, all of its individual components are completely coupled with each other. Meaning, if I want to deploy a firewall, I have to purchase a dedicated firewall hardware, have the necessary firewall OS and license in order to have my firewall service. And this resides as a physical box. Okay, when you go inside the data center, you might also find a firewall there. Okay, in NFV, it differs a bit. Okay, because the functionalities already reside as VM instances, they can in fact be shared using existing hardware resources. That's one feature. You are already decoupling hardware from software. Another feature would be instead of purchasing a dedicated hardware for a specific function only, meaning that I cannot reuse this hardware firewall for something else, in NFV, because you are using commercial off-the-shelf hardware, you can repurpose it. So meaning, I deployed a virtual PGW in my server, and in terms of my capacity, I no longer need that second instance. I can just delete the PGW and have the hardware available for something else. Okay? So, having said that, no, the flexibility of upsizing or downsizing your network can also be scaled automatically, meaning you can also implement automation in your network such that if you only need an X amount of capacity for X amount of time, you can just easily scale up the network, okay? Deploy the necessary network element for it, and when you no longer need it, delete it. Make that resource available for something else. Okay, so this also introduces another feature for NFV, which is the concept of management and orchestration. So there's a difference, in fact, between automation and orchestration. Think of orchestration to be the higher level of automation. Okay, so you also introduce this concept when you deploy NFV. Okay, now, unlike, however, SDN, NFV has a somewhat, I don't want to say strict, no, but it also follows um, sets of standards. So this is akin to how 3GPP would be used for deploying, example, mobile services. So in NFV, you have ETSI. To thank for that, you have the NFV standard architecture, meaning that if you have these components inside your network, no, you have NFV. Okay, so although this might seem daunting at first, no, we can essentially just break down the entire architecture into three basic parts. Yeah. So each of these parts also correspond to the resources available in the NFV architecture. Okay, first off, even though you have NFV, it is deployed as virtualized resources. Remember that you still need hardware for it to run. Therefore, you still have this portion of your architecture, the NFVI. So NFV infrastructure. This is essentially all of the hardware components found in your ecosystem in one domain. Okay? The applications or services running on top of it, it's what's called the virtual network functions themselves, or the VNFs. This is where the example of my virtual PGW, my virtual EMF, my virtual CMF, NSSF, and I'm talking about here 5G core services already, are residing. So the virtual machines themselves, no, when you already assign them a role in your network, they become virtual network functions. And this is where they reside. Now, the one controlling all of your resources is this one, management and network orchestration, or MANO. There is even a running joke in the industry that if you have NFV and you do not have mano, then you do everything mano-mano. So meaning that you only have virtualization in play. You do not have that orchestration part of the architecture, which plays an important role in NFV, because remember, the orchestration plays in the ease of use on how you deploy NFV in your network. Okay, imagine if you want to scale an AMF, for instance. So AMF, this is the control plane of your 5G core, no? If you want to scale an AMF into 4 instances, for example, if you don't have Mano, you have to go inside the individual servers, no, create the VM instances from the ground up, integrate them into your network, no, and then do testing all manually. But if you have this component in your architecture, you have the Mano, no, which actually consists of 3 different parts. No, all you have to do is to, through the orchestrator, create or instruct the VNFM to create the AMF instance, and then it's already the role of the VNFM to call into your infrastructure manager, who will then work with the infra to instantiate the AMFs. So the flow here would be from orchestrator, VNF manager, then to Vim, NFVI, then finally the VNF. So it's all seamless. Okay? So in a bigger picture now, so we've discussed what network functions virtualization is. We also have SDN. We also have OpenFlow. How do these different technologies now work together to ensure or to provide a somewhat seamless ecosystem? Okay. Now, can NFV reside independently without SDN? Yes. Can they also be done vice versa? Meaning, can SDN reside without NFV? Also a yes. Okay. But can they work together? Definitely. They can also work together. So SDN, remember, separates network forwarding functions from control functions. Instead of deploying the SDN functionality as a separate box, why deploy it instead as an instance? Okay, so this is where the concept of NFV comes. NFV abstracts the network functions from the hardware, making it more flexible and available to the entire network. Okay, and have it a bit of an agility capability. For instance, you have your SDN controller deployed in as a VM in one data center. Worst come scenario, that data center goes down. But because you have NFV, I can easily transfer the controller in another data center and have that data center host my controller instead. So that's one application of NFV working with SDN. Another one is the one that you are seeing here in the diagram, wherein the controller is responsible for gluing the different resources found across the different data centers. So NFV supports SDN by providing the infrastructure on which SDN can run. At the same time, it is responsible also for gluing together the different resources regardless of where you want your function to be deployed. So imagine in an ideal world, no, suppose you want to deploy a virtual firewall that is catering all of your subscribers in North Luzon. Okay, it is catering subscribers in North Luzon. But the servers are found in NCR. The storage components are found in Visayas region, no? Your integration points and your packages can be found in the Bicol region. Okay? So all of them are completely disaggregated, but in the network's perspective, they are just one function running coherently. So that is where SDN and NFV can interoperate. Okay? So just to summarize, no, we discussed a lot in our hour and a half overview. No, so what does this leave us? No, and how does now these three technologies support Open RAN in general? So remember that uh, the intention of these technologies is to have the features available for innovation and for from a commercial perspective flexibility. Okay, the main point here is that this also applies. So these are innovation and flexibility, these are somewhat the drivers for Open RAN, no? And this just proves us that even in the core perspective, no, these initiatives can also be applied. They are also applicable and relevant. And they can be provided through having these technologies in mind. Okay, so just a quick recap on what we have discussed in the hour and a half of today's session. No? So we now know that SDN, this is a technology that is essentially it decouples the control plane from the user plane. It consists or it follows a three-layer model, which consists of your application layer, control layer, and infrastructure layer. Okay, three of which are interconnected using application programming interfaces or APIs. Okay, so if you want to have just the boiled down, the essential part, what makes SDN different from conventional IP working, it is infrastructure. Meaning that through SDN, you are essentially decoupling the dependency of the functionality with the infrastructure. Okay? But for us to do that, we then implement another technology which is called NFV, Network Functions Virtualization. Okay?